Alright, you guys, this is Miss Pruitt, and I wanted to make one more video for the evening. Hopefully some of this will be helpful on your homework. But let's talk about limits that do not exist. So, here are only some of the reasons why limits don't exist. Basically, the main reasons why. Number one, the function approaches a different number from the left side of C than the right side. Number two, the function increases or decreases without bound around C. Or three, the function oscillates between two fixed values. Remember, oscillating means it's going back and forth. So let's look at 4 examples. For each limit below, if it exists, find each limit below if it exists. If it does not, tell why it is not a limit. Use a graphing calculator for number 1 and number 2. So, for number 1, the limit as x approaches negative 2 of x squared plus 2 divided by x plus 2. So, I took to my Wabbit app and I picked values on both sides. Let's say this is my x and this is my f of x value. I picked values on both sides, decrease this a little bit, of negative 2. Now, of course, if you plug in negative 2, you're going to get an error. But when I plugged in values on both sides, I was able to tell what was going on with the limit. So the values that I picked that were on the left were like negative 1.999, negative 1.99, negative 1.9. And on the right, I picked negative 2.001. And again, my whole point in doing this is that I want to pick numbers that are really close to my number, since I can't actually put in the exact number that I'm looking for. And that should be a 1 right there. So what I got was 56.1. I got 596. Then I got 5,996. Of course, that's an error. But when I went to the other side, I got negative 6,004, negative 604, and negative 64.1. Well, coming from the left, it looks like this may be increasing all the way to infinity. It doesn't seem like it's stopping. Coming from the right, so it looks like it's going like that. Coming from the right, these numbers are going down, right? Like approaching negative infinity. So since the left does not equal the right, the limit does not exist. And again, my answer is the left limit, the limit is increasing. I'm just going to say, yeah, increasing or decreasing without bound. Think of bound like a boundary. It's a place you can't go, right? It stops. So there's nothing that has bound. It's going on forever and ever. Next example. The limit as x approaches 0 of tangent of 1 over x squared. So I took to my trusty calculator again, and I drew the graph. And then I zoomed in a bit. The graph kind of looked like it went up here, came back down there. Somewhere in the middle, it started oscillating back and forth. Well, and around 0. Anything that's oscillating between two values, backward and forward, it's never going to stop and it's not going to have a bound. So, the limit as x approaches 0 of tangent of 1 over x squared, the limit does not exist. because of its oscillating, we've talked about this in class, our oscillating behavior. So that's why this limit does not exist. Let's look at example number 3. It says find the limit as x approaches 8 of h of x using the function h of x in the table below. So it looks like we're interested in 8 and we're plugging in values of x on the left as well as the right to see what happens. Well, it looks like as we come from the left, our y values are increasing, right? But as we come from the right, it looks like those values are decreasing. Since one side is increasing without bound and the other side is decreasing without bound, the limit as x approaches 8 of h of x does not exist. And again, it's because the values are, or each side is, has a different limit. It's approaching something different on both sides. The left and right limits are not equal. Okay. Last example. Number 4. Use the graph to the right to find the limit as x approaches -3 of f of x. So, I know that I'm interested in x equals -3. I want to find first what's the behavior coming from the left, and then what's the behavior coming to the right. Well, even just looking at it, I can see that the left-hand side limit and the right-hand side limit do not equal each other. So I can tell you right now that the limit as x approaches -3 of this function does not exist. What's the reason why it doesn't exist? Because the left hand, I'm used to saying left hand. Let's say the left side limit does not equal the right side limit. And these are reasons for why the limit may not exist.